Here's a great trig equation to solve. When I look at it, I see a quadratic, so I'm thinking factor. But then if I see two different ratios, you got to have the same ratio. So I'm going to take that first one, the sine squared, and I know there's an identity that says sine squared plus cos squared equals 1. I'm going to move this to the other side, subtract it on each side. So I'll get sine squared x equals 1 minus cos squared x. So everywhere I see this, I'm going to put that. So here it is right there. So 4 times 1 minus cos squared x equals 4 cos x plus 1. Okay, now I just have coses and it's a quadratic, so I need to get things together. Let's distribute this. So I'm going to have 4 minus 4 cos squared x equals 4 cos x plus 1. Now, let's move everything over to the right side so this becomes positive. So it'll be 0 on the left side. I'm going to move this minus 4 over so it'll become positive 4 cos squared x. I'll leave this positive 4 cos x right where it's at. And then I have a plus 1, and now we'll subtract 4 in each side. Okay, so I've got 4 cos squared x plus 4 cos x minus 3. Okay, so it's a quadratic, so I can put 2 brackets. And what I'm thinking of trying, I don't know if it'll work or not. Let's try 2 cos x and 2 cos x. And then maybe if I put a 3 here, positive 3 and a minus 1 there. Let me just FOIL that out to make sure it works. So 4 cos squared x, yeah, plus 6 minus 2 is 4, and minus 1 times 3, negative 3. Yeah, that's right. And it's equal to 0, so I can use the 0 property. So I have 2 cos x minus 1 equals 0, or 2 cos x plus 3 equals 0. Let's start with this one on the right. 2 cos x equals negative 3. Cos x equals negative 3 over 2. And then if you try and arc cos that, this one will come out undefined. So it doesn't work. Let's go to the other side. I'll move the 1 over. Make it positive. Divide both sides by 2. Cos x is equal to a positive a half. So then you'd need to find the reference angle. I think it turns out to be 60 degrees. And so the reference angle is 60 degrees. And so that can happen in 4 places, but cos is positive, so it can only happen here and here. So this angle here is 60 degrees. So that's one of my solutions, and my other solution is that one to there. So it'd be 360 minus 60, or 300 degrees. Now, in the question, I'm not sure if it gave me a domain or a range kind of thing, so you might have to go plus 360k, or you might have to change it to radians, so it'd be pi over 3 and 5 pi over 3, and if they need this thing, you do plus 2 pi times k, something like that. Okay, hopefully that helps you.